right, so previously we discussed indeterminate forms, but when we looked at it, we looked only at infinity over infinity and 0 times infinity. And as you can expect, that's not all the cases that are possible. And there are two other forms of indeterminate forms, including infinity minus infinity and infinity over infinity. Now, infinity minus infinity kind of goes along with everything else you've learned, and that, of course, being that the highest power wins. And that's simply put. It's just the strongest function is going to win. And so it's in determining which one is the stronger function, which one's getting to where you want to go fastest. Who's getting to infinity faster? Who's going to negative infinity? Who's going to 0 faster? And at what rates those are happening. So it does have a lot to do with your slope at that point. But for all intents and purposes, think about which one's the stronger function. And of course, your exponentials tend to be the most significant when we're talking about as we approach to infinity. Now, 0 over 0 also includes some methods. And the first we're going to deal with today, and then tomorrow in your video, you're going to be looking at something we call L'Hopital's rule, which is another trick, another arsenal for when you can't follow these steps. Because if something is 0 over 0, that basically is because that there must be something in common between them, something that can reduce. And so the method that you're going to primarily use is to reduce the fraction first and then take the limit. But you'll find as we approach some of these other questions, there will be times where you cannot simplify it. It's not like something was in common, and so there needs to be another approach. And L'Hopital discovered a neat thing, and so we'll be looking at that in a further video. So let's do some examples. We have the limit as x approaches 0 of x to the 5th over x to the 7th. Now you plug 0 in there, you'd have 0 to the 5th over 0 to the 7th. So we have 0 over 0. Which one is it going to be? So our approach is going to be like this. You're going to basically rewrite our limit as x approaches 0, but we see that the x to the 5th divides into the x to the 7th, leaving me with 1 over x squared. And then we're going to retry. Now, as I've pointed out many times before, because this doesn't say from the right or from the left, we technically should be checking from the right and from the left. And so I would just encourage the 0 plus and the 0 minus. You'll get to where you recognize the fact that since this is squared, then whether it's 0 plus or it's 0 minus, it's going to be the same result, and that is, of course, 1 over 0 plus. And that is infinity. So let's do another one. All right, similar question. Put 0 in there, 0 to the 5th over 0 to the 5th. Once again, 0 over 0. So we're going to simplify. We get the limit as x approaches 0 of 1. So we plug 0 back in, but there's no place to plug the 0 in. So our answer is just 1. Limit as x approaches 3. You plug 3 in, you get 3 minus 3 over 3 minus 3. So again, you get 0 over 0. But we do notice, or at least I hope you do notice, that the x minus 3 and the x minus 3 divide out, and so we're really looking at the limit as x approaches 3 of 1. And again, there's no place to put that, so it's just 1. All right, let's throw this puppy down. All right, plug 3 in again. You have 9 minus 9 on top, or 0 over 0. So we want to simplify, and I hope that you can easily see that this factors, and the x minus 3's once again divide out. So this question, although it looks quite similar to the one above, ends up being the limit as x approaches 3 of x. And so the answer to that one is 3. Limit as x approaches 3, 0 over 0 once again. You simplify this time, and again, it factors just like the one above did, and the x minus 3's end up dividing out. But instead, this is the limit as x approaches 3 of 1 over x. And so this instead is 1/3. Next one, limit as x approaches 3. You have 9 minus 18, or negative 9 plus 9, so it's 0 on the top, 0 on the bottom. Let's simplify it. And so as we simplify the top, it's x minus 3 times x minus 3. And so only one of them cancels out, leaving you the limit as x approaches 3 of x minus 3. And so when you plug 3 in there, you get 0, and this is just 0. Last question, very familiar to the one we have here before. So you simplify. You have the x minus 3, and so that divides out. And so you have the 1 over x minus 3, and you're doing the limit. Oh, but here, when we plug 3 in, you should recognize that you're getting 1 over 0. Well, is it 0 plus or is it 0 minus? And so we have to look at as x approaches 3 plus and as x approaches 3 minus to determine that, and if they do in fact agree. So I plug in 1 over 3 plus minus 3, and of course I get 1 over 0 plus, which would be infinity. And then I do 1 over 3 minus 3, and that would be slightly smaller than 0, and so that would be negative infinity. Since they do not agree, it does not exist.